Okay, so here's your test review for Unit 8. We're going to start with question 1. It says simplify the polynomial and write it in standard form. Well, first to simplify it, we should handle the exponent that is there, which is 3 to the second power. 3 to the second power makes 9. So those are the actual numbers we're going to be dealing with. From there, we're going to start looking for like terms. Remember, you can only combine things that have the same letter with the same exact exponent. 5x squared plus 3x squared would be 8x squared in total. We do not change the exponents, just add the numbers in front. Standard form goes from the highest exponent first, then to the next one that has a letter. There is nothing to combine with this 10x, so we do just bring it down. And then finally, we would have negative 9 minus 9 in this situation. Negative 9 minus 9 would make negative 18. And if you're wondering why I didn't attach that negative when I squared it, it's because it's outside of the parentheses, so they are unrelated. So that is our final answer for standard form. This says how many terms are in the simplified polynomial, where there is 1 here, 2 here, and 3 right here. Terms are separated by plus or minus signs. So there are 3 total terms. The degree of the polynomial is the highest exponent, which in this case is 2. And a leading coefficient is the very first number in front of your highest exponent. So in this case, it is 8. All right, our next one is talking about equivalent expressions. That means once you simplify it, it is equal. Well, this and this are already simplified and they are not the exact same thing. Even if I take out a 2, it doesn't make them the exact same thing. It just doesn't work out, because once I redistribute the 2, I end up back here. They're both simplified and they do not match. The next one's not simplified. We have to simplify it. So we go like this. We get 5x to the 4th power minus 15x to the 3rd. Those are close, but they are not the exact same, so that is not it either. Then we multiply this one, which gives us 5x to the 3rd power minus 15x squared. Well, those are the exact same, so that's great. This one, we're distributing just the x, so we end up with 5x to the 3rd power minus 15x squared. Those are the exact same. And then this one, we have a negative 5 being distributed. This one may trick some of you. Negative 5 times negative 5 is positive 25. And then x squared times x is x to the 3rd power. And then we would do negative 5 times positive 15, which isn't going to give me 15, and I already know that this is not the correct answer. Okay, our next one says find the perimeter of the rectangle. Perimeter is found by adding all 4 sides. Oops. And then we know these sides are equal and these sides are equal. So we basically just add all 4 of those things up and then simplify. Then we combine our like terms. We have 4 5x's, and so that would be 10x plus 10x, which is 20x. And then we have a negative 4 combined with a negative 4, which makes negative 8. These ones are just fancy ways to ask you to find the sum or difference between these 2 expressions. This first one is asking for the sum. It says f of x plus g of x. So we literally just take what f of x is. That's this right here, 8x plus 2. And then we're going to add it with what g of x is, which is 4x minus 3. Well, remember when we're adding, the parentheses don't really matter. They just can go away and we combine those like terms. So we got 8x plus 4x makes 12x, and 2 plus negative 3 makes negative 1. Our next one says g of x minus f of x, so I take g of x, which is 4x minus 3, and then I'm going to subtract 8x plus 2 from it. The parentheses for subtraction are very, very important because remember I have to distribute it before I combine. So we actually have 4x minus 3 minus 8x minus 2. Then we can combine these like terms, which is going to give us negative 4x minus 5. Okay, this number 5 is asking you to find the product of all of these things. So that means we're going to be multiplying. This one's just simple distribution. You just have to remember what to do with those exponents. We multiply the numbers like normal and add the exponents. So this one would be 4x to the third power. This one would be 8x squared. And if there's no x here, you just kind of attach it. So this one would be 16x. And then we have found the product. This one is a negative x squared, so I just kind of change the sign of everything and then add that exponent. X to the fifth, x to the third, and then minus 9x squared. Except I forgot to distribute the negative because that would make this a plus and this a plus. Okay, this one is one of our special cases. You need to remember that this little exponent of 2 means multiply this by itself. And then we use our FOIL method. Y times y is y squared. Y times 2 is 2y. 2 times y is 2y. And 2 times 2 is 4. And then finally, we combine those like terms. And this would be our final answer. Same kind of special case over here. We multiply using the FOIL method, which would be 9y squared minus 12y minus 12y again, and then plus 16. And overall, we have this left over. And then final one is just another FOIL method, and we see what we end up with. So the most common mistake here is going to be combining these two incorrectly. That does not make negative 20 or positive 20. It does not make 1. It makes 0. So we literally just write nothing in between, and this is our final answer. Okay, this next one is just kind of asking you to analyze these two equations, add, subtract, multiply them, and then say some facts about them. So this first one says the difference of f of m and g of m can be represented by this function right here. So that means we actually need to find the difference and see if it matches. So f of m is this, and we need to find the difference from g of m. Remember, distribute that negative before you can combine things. And then you start looking for like terms. Well, 3m to the third power is already a like term, so we can kind of just bring that down. The next one would be, we could do 8m minus m, which makes positive 7m. So far, this equation is looking pretty good. And then this last one would be negative 9 minus 7, which actually makes negative 16. So the issue with this minus 2 is not correct. And we found the right answer. It is this one right here. And do notice that it says, if they aren't correct, find the right answer. Okay, this next one is asking about the sum. So that means we need to add those two things together. So I basically just change that minus sign to a plus. And then I start combining. 3m to the third power has no like terms, so we just bring it down. 8m plus m makes 9m, and then negative 9 plus 7 makes negative 2. This one looks like it is correct. I skipped ahead to this one on accident. This one says the sum of the polynomial is a third degree polynomial. That means the highest exponent is 3, so that is also true. And then the last thing they want us to do is to find the product, and that is the answer to a multiplication problem. So we're going to multiply those two things. And then to multiply something like this, it's like kind of like the long FOIL method. We take this m and we multiply it by everything in the parentheses. So 3m to the fourth power plus 8m squared minus 9m. And then we do the exact same thing with the 7, which would leave us with plus 21m to the third power, plus 56m, and minus 63. Well, as I'm looking at this, even before I simplify it, this is not correct because I don't even see like a third power in this situation, but we should still try to keep solving. Our first term would be 3m to the fourth power because there has no like terms. Next, we want to look at our exponent of 3 to keep it in standard form, so it would be this. 8m squared has no like terms, so we bring it down. And then we combine negative 9m and 56m, which makes 45m. And then finally, the minus 63 has no like terms. So this is a crazy long expression right here, but this was not correct, and this is the correct answer. Okay, now we're into the most like recent stuff that we have learned, and that is factoring. If I see two terms and it is not a difference of squares, I should just kind of start by finding the greatest common factor and seeing if there's anything left to do. So in this case, the greatest common factor is 9, and they both share an x. And then we're left with x squared minus 1. And in this case, on the inside of the parentheses, I do have a special case left over. This is a difference of squares. So I would find my square root of both of those things. We'd have 9x times x plus 1 and x minus 1. Because the formula for difference of squares is like you add and then you subtract. And I knew that there was a difference of perfect squares because it's a subtraction sign and two perfect squares. This next one, we're going to take out our common factors. So in this case, they both share a 5. They both have at least 2 x's and at least 1 y. And then to find the numbers that go on the inside, I divide. 100 divided by 5 is 20. X squared divided by x squared is nothing. And y to the fourth over y to the first would be y to the third. In this case, 5 over 5 makes 1. X squared over x squared makes 1. Y over y makes 1. So this is our final answer. Okay, this one is factor by grouping. This is my first group. This is my second group. This one has a 2, at least 1x, and 2 y's. And then we divide to figure out the numbers that go on the inside. 2 divided by 2 is 1. X to the third power divided by x is x squared. This would also make 1, so we just don't write it. This one would be 6 divided by 2 makes 3. X over x makes 1, and y to the second over y to the second also makes 1. X squared and 3 don't have a common factor besides 1, so we just take out the 1 and keep the inside the same. And now if you look, the insides of the parentheses are the exact same, so we take those out. And then this goes in the other set of parentheses. And that would be our final answer. Okay, this next one is looking like we have a couple trinomials to handle because there are 1, 2, 3 terms. If I check, I should check for perfect squares on either end first to see if it makes my life easier. Unfortunately, 56 is not a perfect square, so we got to go back to this method. Our numbers need to add up to make negative 56. Sorry, I misspoke. They need to multiply up to make negative 56, and they need to add to make positive 1. So the factors of 56 that are going to add up to 1 are negative 7 and positive 8, because the positive number would need to be bigger to end up with this positive. And for this one, there are 2 ways to solve it. You could just jump straight to the final answer, x minus 7 and x plus 8. Or if you went the long way, I will show you how to do it. We would separate this 1x into negative 7x plus 8x. And then we would factor by grouping. And when you factor by grouping correctly, we end up with this right here. Okay, so this next one I'm going to check for perfect squares on either end to see if my life is easier, and in this case it is. So we're going to take the square root of 16 and the square root of 25. And then my formula for a perfect square trinomial that has a minus sign in the middle is this. So my final answer would be 4x minus 5 squared. You could do it the long way, but you are going to have to deal with really big factors. This next one, again, I'm going to check if I have perfect squares on either end, and in this case I do. So I take the square roots, and that's going to give me 2x and 3. And my formula for difference of squares looks like this: a plus b and a minus b. So that's going to be 2x plus 3 and 2x minus 3. This one I'm going to check for perfect squares on either end. On this case, we do not have perfect squares, so that means we have to go back to our traditional diamond x method. To figure out the number that we multiply by, we do 3 times 1, which is 3, and our numbers should add up to make -4, and those factors would be -3 and -1. Because there's a number in front of this x, we have to do factor by grouping to make this factorable. So I would break this up into -3x and -1x. And then we would factor this group and this group. The common factor here would be 3x, leaving us with 1x minus 1. And the common factor here is, since I have this negative in front of the x, I need to take that out, and I'm left with 1x minus 1. And then finally, we have 3x minus 1 times x minus 1. Remember, factor out that common factor. And here is our answer. Okay, these ones say factor completely. These numbers, I should have been looking every single time, but I know these for a fact have greatest common factors. So this one shares a 2, a 4, and a 2, which means they all share a common factor of 2. And then you have 2 ways that you could simplify the inside. I am recognizing right now that it is a perfect square trinomial because there's a perfect square here and a perfect square here, but the x method will also work, whichever way you like better. In this case, I'm going to use the perfect square rule. Again, it is a perfect square with a minus sign in the middle, so our final answer should look like this. So it would be a minus 1 squared. If you did it using the x method, you would find your numbers that multiply to 1 and add to 2, which is -1 and -1. And then our final answer should still end up looking like this, even though you probably wrote a minus 1 times a minus 1. You should just recognize that that can be written with an exponent of 2. Okay, this next one we are checking for common factors because this is not a perfect square and neither is this. 40, 100, and 120 all share a common factor of 20. So we divide all of these things by 20, and we are left with 2y squared minus 10y, minus 5y plus 6. And in this case, we would use the x method to see if we can factor it anymore. Our number should multiply to make 12 and add to make -5. And in this case, that is not possible, so this is actually our final answer. Okay. This one says, which of the following is not a difference of squares? So a difference of squares needs 2 perfect squares with a subtraction sign in the middle after you take out the greatest common factor. So first we should be checking for greatest common factors. For example, 18 and 2 share a 2. And then we're left with that. This one doesn't have any common factors, so we'll just skip to this next one. 8 and 50 share a greatest common factor of 2. And then now we're just kind of looking to see if we're left with perfect squares in this spot and this spot. 9 and 1 are both perfect squares, and that's a subtraction sign, so we're good. 9y to the 4th power and 16 are both perfect squares, so we're good. 4y squared and minus 25 are both perfect squares, so this one's good. And then that just leaves us with this one. 64 is a perfect square, but y to the 9th power is not, because this is an odd numbered exponent. So the way the exponents work is you would divide them by 2, and that would make it a perfect square. I can't do that, so this is not the correct answer. Okay, that is